The universe is an endless expanse of wonder, a cosmic stage where the laws of physics sometimes seem to twist, bend, or even disappear altogether. Out there, in the inky blackness beyond our world, lie mysteries so profound they challenge everything we think we know. Strange signals pulsing from the void, objects moving in ways that defy explanation, and celestial phenomena that even the brightest minds can't fully unravel. These aren't just quirks of space, they're whispers from the unknown, clues to puzzles we're only beginning to understand. And today, we're diving headfirst into the most baffling of them all, the top 25 unexplained space anomalies that continue to leave scientists and stargazers utterly spellbound. Picture this, a star that flickers in ways no natural object should, or a galaxy spinning in the wrong direction against the fabric of cosmic order. These aren't science fiction, they're real, documented enigmas etched into the fabric of our universe. Some of these anomalies have lingered for decades, taunting researchers with questions that refuse easy answers. Others have burst onto the scene more recently, upending long-held theories and sending astronomers back to the drawing board. What if I told you that some of these cosmic riddles might hold the keys to understanding the very nature of reality itself? That's the thrill of space anomalies. They don't just defy explanation, they redefine what we thought was possible. This journey isn't just about cataloging strange phenomena. It's about stepping into the unknown alongside the brave minds who dare to probe its depths. From eerie radio bursts echoing across billions of light years to ghostly structures lurking in the cosmic background, each anomaly we'll explore is a piece of a grander puzzle, one that stretches far beyond our current understanding. And while we may not have all the answers yet, that's what makes this exploration so electrifying. Because in the gaps between what we know and what we've yet to discover, there's magic. So buckle up, by the time we're done, you'll never look at the night sky the same way again. In the summer of 1977, a radio telescope in Ohio picked up something extraordinary, a signal so powerful, so unusual that the astronomer who discovered it scrawled, "Wow." In the margin of the printout, giving this cosmic mystery its unforgettable name. For 72 electrifying seconds, the signal blasted through the void, intense enough to dwarf all background noise, as if the universe itself were shouting directly at us. Then, just as suddenly as it arrived, it vanished, never to be heard again. Decades later, the WOW signal remains one of astronomy's most tantalizing puzzles, a fleeting whisper that defies easy explanation. So what made this signal so special? For starters, it came from the direction of the constellation Sagittarius, a region devoid of any known stars or planets that could have produced it naturally. Its frequency matched the hydrogen line, a bandwidth scientists had long theorized might be used by extraterrestrial civilizations to communicate, since hydrogen is the universe's most abundant element. And then there's the sheer intensity of it, pulsing with a strength that rules out most cosmic interference or equipment malfunctions. It wasn't a satellite, a passing aircraft, or even a distant quasar. It was something else entirely. Theories? Oh, there are plenty. Some researchers argue it could have been a natural event, like a comet's hydrogen cloud reflecting sunlight, except no known comet was in that region at the time. Others suggest it might have been an exotic astrophysical phenomenon we've yet to discover, a cosmic hiccup in the fabric of space. But of course, there's the electrifying possibility that it was artificial, a beacon from an advanced civilization, perhaps intentionally briefed to conserve energy. Imagine that, a deliberate hello from across the stars, sent by minds we can't even fathom, only to slip back into silence before we could reply. What makes the WOW signal so haunting isn't just its mystery, it's the way it embodies the loneliness of our search. For one fleeting moment, the cosmos seemed to answer back, teasing us with the idea that we might not be alone. And then nothing, no repeats, no patterns, no follow-ups, just 72 seconds of pure, unadulterated cosmic intrigue. Scientists have scanned that patch of sky thousands of times since, but the signal remains stubbornly silent. Maybe it was a one-time fluke, a cosmic accident lost to time. Or maybe, just maybe, it was a message we weren't yet ready to understand. Either way, it's a reminder that the universe still has stories to tell, and some of them might just change everything. Now imagine gazing out at the universe, only to realize that entire clusters of galaxies, thousands of them, aren't just drifting aimlessly. They're racing together in a coordinated rush, as if pulled by some invisible hand beyond the edge of everything we can see. Astronomers call this spine-chilling phenomenon dark flow, and it's one of the most unsettling mysteries in modern cosmology. These colossal structures, each containing hundreds or even thousands of galaxies, are moving at staggering speeds, up to 2 million miles per hour toward a single point in space, a place so far away it lies beyond the observable universe itself. So why does this send shivers down the spines of scientists? Because according to everything we understand about the Big Bang and the distribution of matter, this shouldn't be happening. The universe is supposed to expand uniformly, with galaxies scattering like fragments of an explosion. There shouldn't be a direction to their movement, no cosmic current tugging them toward some unseen destination. Yet the data doesn't lie. The Wilkinson microwave anisotropy probe first detected this eerie motion in 2008, and subsequent observations only deepened the puzzle. What could possibly be exerting such a titanic gravitational pull? One theory suggests the presence of a superstructure, something so massive, so unimaginably large, that its gravity bends the fabric of space-time across unfathomable distances. But here's the catch: it would have to exist outside our observable universe, in a region of space so distant that its light hasn't had time to reach us since the dawn of time. Another, even more mind-bending possibility, that we're seeing the gravitational influence of another universe altogether, brushing against ours in the vast multiverse. Then there's the haunting alternative that dark flow might be evidence of a flaw in our most fundamental theories. Could Einstein's general relativity break down on such enormous scales? Or does the mysterious force of dark energy, which already drives the universe's accelerated expansion, play some unknown role in this cosmic stampede? Every explanation feels like grasping at cosmic straws, each one raising more questions than answers. What makes dark flow so captivating isn't just the scale of the phenomenon, it's the way it humbles us. Here we are, mapping the cosmos with astonishing precision, only to stumble upon a mystery that redefines the boundaries of reality itself. Whether it's a hidden supermassive structure, the fingerprint of a parallel universe, or something beyond our current physics, one thing is clear: the universe still holds secrets that refuse to fit neatly into our equations. And that's the beauty of it, because every time we think we've got the cosmos figured out, it finds a way to surprise us all over again. Far out in the constellation Cygnus, a star unlike any other has been playing an impossible game of cosmic peekaboo with astronomers. Known as Tabby's star, officially catalogued as KIC 8462852, this unassuming flicker of light has baffled scientists since its discovery in 2015, when researchers noticed its light was doing something stars simply shouldn't do. Instead of the regular, gentle dips caused by orbiting planets, Tabby's star was plunging into erratic, dramatic drops in brightness, sometimes by as much as 22%, as if something vast and unimaginable were passing in front of it, blotting out its glow in chaotic, unpredictable bursts. At first, astronomers scrambled for ordinary explanations. Could it be a swarm of comets, thousands of them, circling the star in a messy, jumbled orbit? That was the early favorite, until calculations showed it would take an implausible number of comets, far more than any star system should naturally harbor. Next came the possibility of an enormous dust cloud, maybe remnants of a catastrophic planetary collision. But the star's infrared signature didn't match what such an event would leave behind. The more data that came in, the weirder things got. Some dimming events lasted for days, others for weeks, with no discernible pattern. And then there were the long-term trends. Over the past century, Tabby's star has been steadily, inexplicably growing dimmer overall, fading by a staggering 14% between 1890 and 1989 alone. That's when the theories took a wild turn. What if, just if we were seeing the shadows of something artificial? The idea of a Dyson swarm, a colossal array of energy-harvesting structures built by an advanced civilization, sent ripples through the scientific community and the public imagination. It wasn't just sci-fi speculation. The irregular, deep dimming did fit the profile of vast, orbiting megastructures, though no one dared claim it as proof. Even the star's discoverer, Tabby, emphasized the need for skepticism, but the possibility alone was electrifying. Here was a star that might, against all odds, bear the fingerprints of intelligence beyond Earth. Yet with every new observation, the mystery only deepens. Recent studies suggest fine, unevenly distributed dust particles might be responsible for the dimming, but even that raises questions. Why is the dust behaving so strangely? Why does it scatter light in ways that don't quite match known cosmic dust profiles? And why does Tabby's star still occasionally brighten in ways no dust model can explain? The more we learn, the clearer it becomes that this isn't just a puzzle, it's a revolution in how we understand stars and what might lurk around them. Tabby's star is a reminder that the universe thrives on the unexpected. Whether it's an undiscovered natural phenomenon or something far more extraordinary, this flickering enigma challenges us to rethink the boundaries of the possible. And until we have definitive answers, it stands as a beacon, not just of light, but of all the cosmic wonders still waiting to be unraveled. We live in a galaxy teeming with hundreds of billions of stars, many of them orbited by planets in the so-called Goldilocks zone, that perfect pocket of space where life as we know it could thrive. With numbers like these, the universe should be buzzing with civilizations, their radio signals crisscrossing the cosmos, their megastructures dotting the sky. And yet silence, an eerie, unsettling nothingness. This glaring contradiction is the heart of the Fermi Paradox, a puzzle so profound it forces us to question everything we think we know about our place in the cosmos. If life is so likely, where is everyone? One of the most chilling answers lies in the concept of the Great Filter, a hypothetical barrier so devastating that it prevents life from progressing to interstellar stages. Think of it as a cosmic gauntlet, a series of challenges so extreme that almost no civilization survives them. The terrifying part, we don't know if we've already passed this filter. Maybe we're the rare exception that made it through, or if it still lies ahead, waiting to wipe us out. Nuclear war, climate collapse, runaway AI, any of these could be the universe's way of hitting the reset button. The silence out there might not be emptiness, it could be a graveyard. Then there's the zoo hypothesis, a gentler but no less unsettling idea. Imagine advanced civilizations watching us like animals in a cosmic nature preserve, deliberately avoiding contact until we reach some evolutionary milestone. It sounds like science fiction, but it would explain why we haven't stumbled upon any obvious signs of alien engineering. Maybe they're out there, observing, waiting for us to grow up as a species before they say hello. Or worse, maybe we're just not interesting enough to warrant their attention. Other theories push the boundaries of imagination. Could intelligent life inevitably destroy itself through technological progress? Or do civilizations expand so quickly that they burn through resources before they can colonize the stars? There's even the haunting possibility that we're alone, that through some fluke of physics or chemistry, Earth is the only place where life ever took hold in this vast, indifferent universe. What makes the Fermi Paradox so captivating isn't just the lack of answers, it's the way it holds up a mirror to humanity. Every possible solution forces us to confront our own fragility, our potential, and our place in the grand scheme of things. Are we the first, the last, or just one fleeting whisper in an endless cosmic silence? Until we know for sure, the paradox remains one of science's most profound mysteries, a question that doesn't just seek aliens, but forces us to ask what it truly means to be alive in the first place. One moment, the cosmos is silent. The next, a blast of radio energy so powerful it outshines entire galaxies erupts across the universe, then disappears without a trace, lasting barely a millisecond. These are fast radio bursts, some of the most explosive and mysterious phenomena ever detected in space. First discovered in 2007, these intense flashes originate billions of light-years away, far beyond our Milky Way, packing more energy in a blink than our Sun releases in 80 years. And here's what keeps astronomers up at night. We still don't know what's causing them. The strangeness doesn't stop there. Most FRBs are one-off events, cosmic firecrackers that ignite and vanish forever. But a handful defy expectations by repeating, crackling through the void at irregular intervals with no discernible pattern. Take FRB 1211-2, the first repeater ever found. Nestled in a dwarf galaxy 3 billion light-years away, it sporadically erupts in clusters, sometimes going silent for months before firing off dozens of bursts in a single day. It's as if the universe is teasing us, offering glimpses of something extraordinary while hiding the rules of the game. So what could possibly generate such titanic, fleeting bursts? Neutron stars, those ultra-dense corpses of exploded stars, are the leading suspects. Some researchers point to magnetars, a type of neutron star with a magnetic field a quadrillion times stronger than Earth. When these cosmic powerhouses undergo starquakes, their crusts might rupture, releasing pent-up energy in explosive waves. Then there's the cosmic comb theory. Imagine a pulsar, another kind of spinning neutron star, slinging out beams of radiation like a lighthouse. If those beams plow through a cloud of plasma, they could amplify into the intense, fleeting spikes we detect as FRBs. But let's talk about the elephant in the room, the possibility, however slim, that we're picking up something artificial. Could these bursts be interstellar beacons or even the byproduct of alien propulsion systems? The repetitive ones especially raise eyebrows. Why would a natural phenomenon turn on and off like a malfunctioning cosmic transmitter? Even the most skeptical scientists admit it's a tantalizing thought, though the lack of any discernible encoded information keeps this theory firmly in the fringe. Here's where it gets even weirder. In 2020, astronomers detected something unprecedented, an FRB inside our own galaxy, paired with an X-ray burst from a known magnetar. This was a smoking gun, linking at least some FRBs to these extreme stellar objects. And there's always a but, this burst was thousands of times weaker than the distant ones. So while it solved one piece of the puzzle, it deepened another. How do magnetars in distant galaxies produce bursts so much more powerful? Every new detection peels back another layer of mystery. Some FRBs show bizarre, scattering patterns, their signals stretched and distorted as if they've traveled through turbulent clouds of ionized gas. Others arrive with a polarization twist, hinting at incredibly strong magnetic fields at their source. Each clue feels like another brushstroke in a painting we're still struggling to see clearly. Fast radio bursts are more than just cosmic oddities, they're probes into the most extreme environments in the universe. With every burst, we're glimpsing the unimaginable forces at play in the hearts of distant galaxies and maybe, just maybe, catching whispers of something even more extraordinary. One thing's certain, until we crack their code, these fleeting flashes will keep us chasing shadows in the dark. In October 2017, astronomers spotted something streaking through our solar system that shattered all expectations. An object so strange, so utterly alien, that it sparked one of the most heated debates in modern astronomy. Named Oumuamua Hawaiian for Scout, this interstellar visitor was the first confirmed traveler from another star system, tumbling past us at blistering speeds. But it wasn't just its origin that stunned scientists. Everything about Oumuamua defied explanation, from its bizarre shape to the way it moved, as if the cosmos had tossed us a riddle wrapped in cosmic enigma. First, there was its form. Unlike any natural space rock we'd ever seen, Oumuamua wasn't round or even lumpy. Observations suggested it was shaped like a pancake, or maybe a cigar stretched out to nearly 10 times longer than it was wide. Picture a tumbling silo hurtling through space, reflecting sunlight in erratic bursts as it spun. This alone was unprecedented. Most asteroids and comets are roughly spherical, shaped by eons of collisions. Oumuamua's extreme proportions hinted at a violent past, perhaps sheared apart by gravitational forces or sculpted by processes we've never witnessed. Then came the real head-scratcher, its acceleration. As Oumuamua sped away from the sun, it didn't just coast on gravity's pull, it sped up, as if nudged by some unseen force. Normally, this would scream comet, since icy bodies vent gas when heated, creating a natural propulsion system. But here's the kicker: Oumuamua showed no visible coma or tail, no telltale haze of dust or gas that telescopes could detect. It was as if the object had ghosted through the solar system, playing by rules we didn't understand. Cue the scientific showdown. Mainstream astronomers scrambled for conventional explanations. Maybe Oumuamua was a rare, dark comet, its outgassing happening in ways our instruments couldn't see. Or perhaps it was a fragment of a Pluto-like world, blasted free by some cataclysm, its surface rich in nitrogen ice that vaporized stealthily. Each theory had holes. If it was a comet, why no debris? If it was a shard of a dwarf planet, why hadn't we seen others like it? Enter the more provocative interpretations. Harvard astronomer Avi Loeb famously floated the idea that Oumuamua might be artificial, a solar sail or probe from an advanced civilization, its thin shape perfect for catching stellar winds. The object's reflectivity, its acceleration, even its trajectory, which some argued was oddly optimized for a solar fly, all raised eyebrows. Loeb didn't claim proof, merely that we shouldn't dismiss the possibility outright. The backlash was fierce, with critics calling it sensationalism, but the debate ignited a crucial question: how do we distinguish between the truly natural and the unthinkably artificial when we're dealing with phenomena we've never seen before? What makes Oumuamua so endlessly fascinating isn't just the mystery of its origin, it's the way it exposed the limits of our knowledge. Here was an object that spent, at most, a few weeks in observable range, leaving behind a trail of questions and no second chances. By the time we knew enough to look closely, it was already vanishing into the void, becoming one of science's great what-ifs. Was it a weirdly shaped rock, a cosmic iceberg, or something else entirely? We may never know for sure, but its fleeting visit taught us something invaluable. The universe is far stranger, far more inventive than we ever imagined. And the next interstellar visitor, well, we'll be ready, or at least we'll hope we are. For decades, a shadow has lurked in Earth's orbit, an object whispered about in hushed tones, its origins wrapped in layers of myth and mystery. They call it the Black Knight satellite, and if the stories are to be believed, it's been watching us for 13,000 years, an alien sentinel silently circling our planet. The legend paints a thrilling picture, an ancient artifact of unknown intelligence, possibly sending signals we've yet to decode, its purpose as inscrutable as its creators. But beneath the allure of this cosmic fairy tale lies a far stranger truth, one woven from misidentified debris, Cold War paranoia, and the human knack for seeing patterns in the noise of the universe. The myth first took root in the 1950s when newspapers buzzed with reports of unidentified objects in orbit. At the height of the space race, both the U.S. and Soviet Union were tight-lipped about their satellite launches, fueling speculation that something else might be up there. Then, in 1960, a series of eerie radio signals, slow, deliberate pulses, were picked up by researchers. Some claim they matched no known natural source, sparking whispers of an alien transmitter. But here's the twist: those signals were later traced to a passing U.S. satellite, their mysterious pattern nothing more than routine telemetry. The legend snowballed in the 70s when images from NASA missions seemed to show a dark, angular object floating near Earth. Conspiracy theorists seized on these grainy photos as proof of the Black Night, except the object was often debris, a lost thermal blanket, or even a camera lens cap drifting in microgravity. The most infamous photo, circulated for years as smoking gun evidence, was actually a shot of the STS-88 mission's discarded insulation panel tumbling harmlessly in the void. So why does the myth persist? Part of it lies in our love for a good mystery. The idea of an ancient alien satellite taps into something primal, the fear or hope that we're not alone. There's also the seductive power of coincidence. In the 90s, a misinterpretation of Nikola Tesla's early radio experiments got tangled into the lore, with claims he'd intercepted Black Night signals in 1901. Never mind that Tesla himself never mentioned such a thing. The pieces fit just well enough to keep the story alive. But here's the real kicker: Earth's orbit is full of strange, silent watchers, just not the kind conspiracy theorists imagine. Thousands of derelict satellites, spent rocket stages, and fragments of collisions form a ghostly junkyard around our planet. Some, like the Vanguard 1 satellite launched in 1958, still circle decades after their missions ended, their metal husks outliving the engineers who built them. These are humanity's real relics, haunting reminders of our first fumbling steps into space. The Black Night myth endures because it reflects something deeper than facts. It's a mirror for our anxieties and aspirations. In a universe that grows vaster with every discovery, we ache for proof that someone, something out there has noticed us. And while the truth may be less dramatic than an alien satellite, it's no less extraordinary. Because every time we unravel one of these cosmic tall tales, we're reminded of the real wonders still waiting to be found. No ancient aliens required. Deep in the cosmos, where swirling clouds of gas and dust typically birth stars in chaotic splendor, one nebula stands out like a cosmic rebel: the Red Rectangle. Named for its striking geometric appearance, this celestial structure isn't just visually stunning. It's a full-blown astrophysical anomaly. Most nebulas billow and curve like smoke in zero gravity, but the Red Rectangle taunts convention with its sharp, almost manufactured X-shape, as if the universe itself took a ruler to the heavens and etched lines into the void. So what could possibly carve such precise symmetry into a stellar nursery? The leading theory points to an elderly duo at the nebula's heart, a pair of aging stars locked in a gravitational dance. As these stars shed their outer layers near the end of their lives, their interactions might sculpt the surrounding gas into that iconic X. Imagine two spinning tops wobbling in tandem, their movements stirring the cosmic dust into crisp, angular waves. But here's the catch: while binary systems are common, none we've found produce such extreme geometric perfection. The Red Rectangle's crisp edges and ladder like rungs of glowing material defy even the most generous simulations. Then there's the color, that eerie, blood-red hue that gives the nebula its name. Unlike the vibrant blues and pinks of younger nebulas, this one's glow comes from a rare form of carbon-rich molecules illuminated by the dying stars at its core. These organic compounds, dubbed polycyclic aromatic hydrocarbons, are the same building blocks found in soot and deep space dust clouds. But in the Red Rectangle, they're arranged in a way that amplifies their crimson glow, painting the nebula in shades that feel almost supernatural. The real puzzle, though, isn't just how it looks, it's how it persists. Structures this precise should dissolve into chaos over time, their edges blurred by stellar winds and radiation. Yet the Red Rectangle's X-shape has held firm for centuries, maybe millennia. Some researchers speculate that jets of material, ejected perpendicularly from the star's poles, could be reinforcing the structure like cosmic scaffolding. Others wonder if magnetic fields, invisible and powerful, are acting as celestial stencils, channeling the nebula's glow into those razor-sharp lines. What makes this nebula so mesmerizing isn't just its defiance of expectations, it's the way it challenges our very understanding of stellar evolution. Most dying stars create sprawling, asymmetrical planetary nebulas, their ejected material expanding in all directions like a burst balloon. The red rectangle, though, feels deliberate, almost designed. It's a reminder that even in the vast, seemingly lawless expanse of space, there are patterns we've barely begun to decode. And until we crack its secrets, it will keep glowing defiantly, a geometric enigma written in light and dust. Picture a vast cosmic desert, a region so staggeringly empty that it defies everything we know about the universe's structure. This is the Bootes Void, an incomprehensible stretch of space spanning 330 million light-years, where galaxies are almost entirely absent. Nicknamed the Great Nothing, this void isn't just a gap, it's a gaping hole in our understanding of how matter arranges itself across the cosmos. If you drop the Milky Way into the Bootes Void, its nearest galactic neighbor would be so far away, our night sky would appear nearly black, devoid of the glittering tapestries we take for granted. When astronomers first stumbled upon this void in the 1980s, the discovery sent shockwaves through the scientific community. According to our best models of the universe, matter should be distributed relatively evenly, with galaxies clustering like froth on the surface of an ocean. But the Bootes Void flips that expectation on its head. Instead of a sponge-like structure, we find a region where galaxies are vanishingly rare. Only 60 or so have been spotted in a space that should contain thousands. It's as if someone carved out a sphere of the universe and left behind a cosmic ghost town. So how does something this empty even exist? One theory suggests it might be the result of smaller voids merging over billions of years, like soap bubbles combining into one enormous cavity. Another, more tantalizing idea points to the void as evidence of an ancient collision with a parallel universe, a bruise left behind by a multiversal accident we can't yet prove. Then there's the unsettling possibility that the void isn't empty at all, but filled with something we can't see. Dark matter so exotic it doesn't interact with light, or rogue black holes drifting like silent predators in the dark. But here's where it gets even stranger. The Bootes Void isn't just a scientific curiosity, it's a philosophical challenge. If regions like this exist, how many others lurk undetected in the universe's uncharted depths? Could they be evidence of forces or phenomena beyond our current physics? Or are they simply cosmic flukes, statistical outliers in a universe that thrives on chaos? What makes the Bootes Void so haunting isn't its emptiness, it's the echo of all the questions it leaves unanswered. A hole this vast forces us to confront how little we truly grasp about the cosmos. And until we peer deeper into the darkness, it will remain one of the universe's most humbling mysteries, a great nothing that somehow says everything. Imagine a world where time itself is fractured, where a single second stretches into eternity under the crushing grip of gravity, so intense it bends reality. Now picture planets somehow surviving in that nightmare, orbiting the corpse of a star that died in one of the universe's most violent explosions. Welcome to the bizarre realm of pulsar planets, cosmic survivors that defy every rule we thought we knew about how planets form and how they perish. The story begins in 1992, when astronomers studying a rapidly spinning pulsar named PSRB 1257+12 noticed something impossible. Pulsars, the dense, city-sized remnants of supernova, should be the last place you'd find planets. When a massive star goes supernova, the explosion unleashes enough energy to vaporize nearby worlds 10 times over. Yet there they were, tiny, rhythmic wobbles in the pulsar's otherwise perfect spin, betraying the gravitational tug of not one, but two planets dancing around this stellar gravestone. How could anything survive such apocalypse? One theory suggests these planets might be cosmic phoenixes born from the ashes of the explosion itself. When the progenitor star died, the supernova's shockwave could have compressed surrounding debris into a new disk of material, a second-chance nursery where planets coalesced from the wreckage. It's a haunting thought, worlds forged in fire rising from the corpse of their own destruction. Then there's the darker, more violent possibility that these planets weren't survivors at all, but invaders. Pulsars often lurk in binary systems, and if one star goes supernova, its companion might be torn apart by tidal forces, scattering fragments into orbit. Over time, those fragments could collide and merge, assembling themselves into new worlds under the pulsar's relentless glare. Imagine the scene: a stolen star shredded into planetary building blocks, then reassembled by gravity into something entirely new. But the real jaw-dropper came in 2006, when researchers found a third planet orbiting the same pulsar, this one so small it was dubbed a cosmic pebble. At just 0.02% of Earth's mass, it shouldn't exist either. Current models struggle to explain how such a tiny object could form in the chaos following a supernova, let alone persist in the pulsar's lethal radiation belts. And that's the true shock of pulsar planets. They force us to rewrite the textbooks. These aren't just oddities, they're proof that planetary systems can emerge in environments we once thought sterile. Some pulsar planets even show hints of exotic compositions, worlds made of diamond, perhaps, forged under pressures beyond imagination. Others might be bathed in perpetual auroras, their skies lit by the pulsar's deadly beams like cosmic lighthouses. What makes these discoveries so thrilling isn't just their defiance of physics, it's the doors they open. If planets can form around dead stars, what other impossible worlds are out there waiting in the dark? Each pulsar planet whispers the same tantalizing promise: the universe is far stranger, far more inventive than we ever dreamed. And the next time we point our telescopes at the void, we might just find something even more extraordinary. Somewhere beyond the Milky Way's glittering disk, hidden behind a wall of stars and dust so thick our telescopes can barely pierce it, lurks one of the most powerful gravitational mysteries in the universe, the Great Attractor. This colossal anomaly, with the mass of tens of thousands of Milky Ways combined, is yanking our entire galaxy along with thousands of others toward it at over 14 million miles per hour. Yet for decades, its true nature remained veiled by what astronomers call the zone of avoidance, a region so obscured by our own galaxy's interstellar debris that it's like trying to peer through a cosmic blindfold. This gravitational enigma first came to light in the 1970s, when scientists mapping the motions of galaxies noticed something unsettling. Everything in our corner of the universe, from the Milky Way to distant clusters hundreds of millions of light-years away, was streaming toward the same invisible point in space. It wasn't just drift, it was a coordinated rush, as if the cosmos itself were sliding downhill toward some unseen abyss. The problem, when they pointed their telescopes toward the suspected epicenter in the constellation Norma, they found almost nothing, just a smudge of dim galaxies, nowhere near massive enough to explain the pull. The breakthrough came when astronomers realized the Great Attractor isn't a single, monstrous object. It's likely the heart of the Laniakea supercluster, a sprawling web of galaxies spanning 500 million light-years. At its core lies the Norma cluster, a dense knot of galaxies and hot gas, along with hidden concentrations of dark matter weaving an immense gravitational net. But even this doesn't fully account for the motion. Recent studies suggest the Great Attractor might just be a waypoint in an even grander cosmic current, one leading toward the unfathomably massive Shapley supercluster, nearly 700 million light-years beyond it. Studying this invisible giant has required ingenious workarounds. Infrared and radio telescopes capable of slicing through the zone of avoidance's dust revealed galaxies previously drowned in the Milky Way's glare. X-ray observatories mapped the superheated gas swirling around the attractor's core, betraying its gravitational might. Each new observation peels back another layer of the mystery, but the deeper we look, the more questions emerge. Why is the pull so strong? What role does dark energy play in this cosmic tug of war? And could there be structures beyond the great attractor orchestrating motions we've yet to detect? What makes this gravitational puzzle so captivating isn't just the scale, it's the humility it demands. We're literally being dragged towards something we still don't fully understand, a reminder that even as we map the universe, vast forces operate just beyond our sight. The Great Attractor isn't just pulling galaxies, it's pulling our curiosity into the unknown, challenging us to look deeper, push farther, and question what else might be hiding in the shadows of the cosmos. Most galaxies follow a familiar blueprint: spirals with curving arms, ellipticals like glowing clouds, or chaotic irregulars, but Hoag's object defies all expectations. Discovered in 1950 by astronomer Arthur Hoag, this celestial oddity appears as a perfect ring of young blue stars, floating serenely around a golden core with nothing visibly connecting them. No twisting spiral arms, no trailing dust lanes, just a cosmic bull's-eye hanging in space, so symmetrical it looks almost designed. And that's what makes it one of the most baffling structures in the known universe, a galaxy that shouldn't exist according to our current understanding of how galaxies form and evolve. At the heart of the mystery lies the ring itself, a luminous circle spanning 120,000 light-years wider than our Milky Way, sparkling with clusters of hot, newborn stars. Normally, rings like this form when smaller galaxies punch through larger ones, sending shockwaves through their gas clouds and triggering star formation in rippling circles. But Hoag's object shows no signs of such violence. There's no debris, no distorted core, no trail of stars hinting at a past collision. Instead, the ring floats around the central core like a hula hoop around a dancer, separated by a vast, empty gap of near-total darkness. This bizarre structure has forced astronomers to rethink galaxy formation entirely. One leading theory suggests Hoag's object might be an extreme example of a resonance ring, where gravitational instabilities in the galaxy's disk cause gas to pile up in waves, creating perfect circular bands of star formation. But even this explanation struggles to account for the sheer precision of the ring, or the eerie emptiness between it and the core, another possibility. That we're witnessing the aftermath of a cosmic merger so ancient, all traces of the collision have faded, leaving behind only this sculpted ring as a ghostly echo. Then there's the strangest twist of all. In 2002, astronomers peering even deeper into the void behind Hoag's object spotted another ring galaxy, faint but unmistakable, lurking in the distant background. The odds of two such rarities lining up perfectly by chance are astronomically slim, raising spine-tingling questions. Could there be some unknown mechanism, some overlooked quirk of physics, that makes ring galaxies more common than we thought? Or is the universe simply teasing us with a celestial coincidence, daring us to dig deeper? What makes Hoag's object so mesmerizing isn't just its beauty, it's the way it exposes the gaps in our knowledge. Here's a galaxy that looks like it was assembled by an artist's hand, yet it follows rules we're still struggling to decode. Every observation peels back another layer of mystery, and with no clear answers in sight, it stands as a humbling reminder. Even in a universe brimming with wonders, some enigmas refuse to be neatly explained. Think about the last time you held a snow globe, how the glitter swirls around the center when you shake it, obeying unseen forces that keep it from flying apart. Now imagine that same principle applied to an entire galaxy, where stars orbit at breakneck speeds around a central core. But here's the catch: there's not enough visible matter to hold them together. This cosmic discrepancy, stars moving too fast for the gravity we can see, was the first clue that the universe is hiding something monumental. We call it dark matter, an invisible scaffold woven through the cosmos, holding galaxies together like phantom glue. The evidence for dark matter is as pervasive as it is puzzling. Start with galaxy rotation curves. In the 1930s, astronomer Fritz Zwicky noticed something odd about the Coma cluster. Its galaxies were moving so fast they should have flung themselves apart long ago. Decades later, Vera Rubin's meticulous observations of spiral galaxies confirmed the pattern. Stars at the outer edges orbited just as quickly as those near the center, defying Newton's laws. Without some unseen mass anchoring them, these galaxies would have unraveled like spinning tops losing their grip. Then there's gravitational lensing, nature's own magnifying glass. When light from distant galaxies bends around massive objects, it creates distorted, stretched images, a phenomenon Einstein predicted. But here's the twist: often, the bending is far more extreme than visible matter can explain. Take the Bullet cluster, where two galaxy clusters collided. The visible gas, slowed by friction, lagged behind, while the bulk of the mass, revealed by lensing, raced ahead like a ghostly shadow. Whatever this missing mass is, it doesn't interact with light or ordinary matter. It simply is, exerting gravity without leaving a trace. Yet for all its influence making up 27% of the universe's mass-energy budget, dark matter remains frustratingly elusive. We've built detectors deep underground, shielded from cosmic noise, hoping to catch a fleeting interaction. We've mapped its distribution through painstaking surveys, revealing vast cosmic webs that guide galaxy formation. Some theories suggest it's a sea of weakly interacting massive particles, or WIMP, while others propose primordial black holes or even exotic quantum fields. But after decades of searching, no single explanation fits all the clues. What makes dark matter so electrifying isn't just its invisibility, it's the way it forces us to question the very fabric of reality. Every galaxy, every cluster, every ripple in the cosmic microwave background whispers the same truth. We're surrounded by something fundamental, something real that we can't see, touch, or even fully comprehend. And until we crack its code, the universe will keep holding its greatest secret just beyond our grasp. In a universe where dark matter is supposed to be the unseen scaffolding holding galaxies together, one celestial rebel refuses to play by the rules. Meet NGC 1052DF2, a ghostly galaxy that spins through space with almost none of the mysterious substance we've come to expect, a cosmic heretic that's shaking the foundations of modern astrophysics. Discovered in 2018, this enigmatic smudge of stars isn't just unusual. It's a direct challenge to everything we thought we knew about how galaxies form and survive. At first glance, DF2 looks like any other ultra-diffuse galaxy, a wispy collection of stars so sparse you could practically see right through it. But when astronomers measured the motion of its star clusters, they stumbled upon something extraordinary. Unlike every other galaxy studied, DF2's stars were moving exactly as fast as the visible mass could account for. No extra gravity, no hidden dark matter needed. It was as if someone had taken a standard galaxy and stripped out its invisible skeleton, leaving behind a celestial paradox drifting through the void. The discovery sparked immediate controversy. Skeptics argued it might be a simple case of miscalculation. Perhaps DF2 was closer or farther away than believed, throwing off the measurements. Others wondered if tidal forces from a neighboring galaxy had ripped away its dark matter, though none loom large enough in its vicinity to explain such a dramatic theft. The most tantalizing possibility, that DF2 is exactly what it appears to be, a galaxy born without dark matter altogether, a freak of nature that forces us to rewrite the rules. Here's why this shakes the cosmic chessboard. For decades, dark matter has been the linchpin of galaxy formation theory. Without its gravitational pull, models suggest galaxies like ours could never have spun into existence. Yet DF2 exists calm and stable, as if taunting us with its very survival. Some theorists propose it might be a failed galaxy, born from gas too thin to attract much dark matter in the first place. Others speculate it could be the debris of a violent collision, a galactic refugee cast adrift without its invisible anchor. But the plot thickens. Just 1 year later, astronomers found another dark matter deficient galaxy NGC 1052 DF4, a near twin of DF2 lurking in the same patch of sky. Two outliers in one corner of the universe can't easily be dismissed as flukes. Could there be an entire population of these oddballs, hinting at a formation process we've never considered? Or worse, what if our understanding of dark matter itself is incomplete, and these galaxies are showing us a side of physics we've yet to imagine? The mystery of DF2 isn't just about a single galaxy, it's a crack in the foundation of cosmology. Every time we think we've pinned down the universe's rules, it throws us a curveball, daring us to think bigger. Whether DF2 is a cosmic accident, a measurement error, or a signpost to new physics, one thing's certain: the more we search, the more the universe reminds us how much we still have left to learn. When we peel back the layers of the universe to its earliest moments, we're left staring at an echo. The cosmic microwave background, a faint glow from the Big Bang itself. This ancient light serves as the ultimate baby picture of our cosmos, a snapshot frozen in time when everything was just cooling off from the unimaginable heat of creation. But within this primordial tapestry, one detail stands out like a cosmic bruise: the cold spot. Stretching nearly 2 billion light-years across, this mysterious patch is significantly colder than its surroundings, as if someone took a scoop out of the universe's energy and left behind an icy void where warmth should be. The discovery of the cold spot wasn't just another oddity, it was a challenge to our understanding of how the universe evolved. Normally, tiny fluctuations in the SIMB are expected, the predictable wrinkles of a growing cosmos. But this was like finding a frozen lake in the middle of a desert. The odds of such a massive cold region forming naturally were calculated at less than 2%, leaving scientists scrambling for explanations. Could it be a statistical fluke, a glitch in our measurements, or something far more profound? One spine-tingling theory suggests we might be seeing the shadow of a collision with another universe. In the multiverse hypothesis, where countless bubble universes float in an endless higher dimensional sea, it's possible that our cosmos once brushed against a neighbor. The energy drain from that encounter could have left behind this colossal cold imprint, like a cosmic fingerprint pressed into the fabric of reality. It's the kind of idea that sounds like science fiction, except the math, at least in some models, holds up. But before we leap to parallel universes, there are other, less extravagant possibilities. Maybe the cold spot is a vast supervoid, an enormous region of space unusually devoid of galaxies and matter. As light travels through such a void, it loses energy, stretching into longer, cooler wavelengths, an effect known as the integrated Sachs-Wolf effect. The trouble is, even the largest known voids don't come close to explaining the cold spot's extreme chill. It's like trying to cover a glacier with a bedsheet, the scale just doesn't match. Then there's the unsettling chance that we're misreading the data entirely. Could instrument noise or foreground interference from our own galaxy be masking the truth? Multiple telescopes from Planck to WMAP have confirmed the cold spot's existence, but the debate rages on. Some researchers argue that our statistical models are flawed, that given enough universe to study, anomalies like this are inevitable. Others counter that dismissing it as a fluke risks ignoring what might be the most important clue we've ever found. What makes the cold spot so riveting isn't just its mystery, it's the way it forces us to confront the limits of our knowledge. Here's a feature written into the very first light of the cosmos, and we still can't agree on what it means. Whether it's a window into the multiverse, a cosmic illusion, or a sign that our physics is incomplete, one thing is certain: the universe is still full of surprises. And the cold spot, it's the chill down our spines, reminding us that some secrets are written in the coldest, oldest light of all. Most black holes anchor themselves to the fabric of the cosmos, tethered by gravity to the stars they once were or the galaxies they dominate. But not all play by those rules. Lurking in the darkness between stars, rogue black holes drift untethered cosmic nomads with no fixed address, no stellar companions, and a terrifying habit of slipping through the universe unseen. These invisible wanderers, some weighing as much as billions of suns, are among the most elusive and unsettling phenomena in space, and the scariest part. We may never know how many are out there or how close they've come to us. Detecting these lone predators is like tracking ghosts. Without stars or gas to feed on, they don't emit the telltale X-ray glow of their stationary cousins. Instead, astronomers rely on a phenomenon called gravitational microlensing, a fleeting distortion of light when a black hole's gravity warps the path of a distant star's rays, briefly magnifying it like a cosmic magnifying glass. It's a subtle effect, lasting mere days or even hours, and requires telescopes to scan millions of stars just to catch a handful of candidates. In 2018, one such event, dubbed the Unicorn, revealed a rogue black hole just 5,000 light-years away, its presence betrayed only by the way it bent the light of a single, unlucky star behind it. Where do these drifters come from? The leading theory points to galactic violence. When galaxies collide, their central supermassive black holes eventually merge, but the titanic forces involved can slingshot smaller black holes into the void like cosmic bowling balls. Another possibility is that some were born rogue primordial black holes forged in the chaos of the early universe before galaxies even existed. These ancient relics could still be wandering, untouched by time, their origins lost to the depths of cosmic history. Then there's the chilling implication. If rogues are this hard to spot, could one already be moving through our corner of the galaxy? Unlike asteroid impacts or solar flares, a close encounter with a wandering black hole wouldn't give us any warning. It wouldn't shred planets with radiation or bathe us in deadly light. It would simply warp space around it, tugging at the edges of our solar system with invisible fingers, altering orbits in ways we might not notice until it was too late. But here's the twist: rogue black holes might also be the architects of cosmic mysteries we've yet to solve. Some researchers speculate they could be the hidden force behind certain hypervelocity stars, those rare celestial bodies rocketing through space at speeds too intense for ordinary stellar interactions. Others wonder if they might explain dark matter's gravitational pull, though the math doesn't quite add up yet. What makes these drifters so fascinating isn't just their stealth, it's the way they defy our attempts to categorize the cosmos. They remind us that even the most extreme objects in the universe can slip through the cracks of our understanding, silent and unseen, rewriting the rules as they go. And with every microlensing event, every distorted star, we're left wondering, how many more are out there moving through the dark, waiting to reveal themselves? The sun isn't just a seething ball of plasma. It's a cosmic sculptor bending the very fabric of space around it with invisible magnetic forces. But in 2019, NASA's Parker Solar Probe uncovered something no one expected. The solar wind, that stream of charged particles racing outward from the sun, isn't smooth or steady. Instead, it's riddled with bizarre, hairpin turns in the magnetic field, flips so sharp and sudden that scientists dub them switchbacks. Picture riding a highway where the road suddenly twists into an S-shape, tossing your car sideways without warning. Now imagine that happening in the sun's atmosphere, where magnetic fields whip around at hundreds of thousands of miles per hour. That's the chaos Parker witnessed, and it's rewriting the rules of how stars work. These switchbacks aren't just quirky wrinkles in space, they're violent, explosive events. Lasting anywhere from seconds to hours, they send charged particles zigzagging like pinballs, reversing direction so abruptly that the magnetic field effectively folds back on itself. At first, researchers thought they might be glitches, turbulent eddies in the solar wind. But Parker's data revealed something far more profound. These kinks are fundamental to how the sun releases energy. Some theories suggest they're caused by magnetic reconnection. a process where field lines break and explosively realign like rubber bands snapping into new shapes. Others argue they're driven by plasma jets erupting from the sun's surface, flinging twisted magnetic loops into space like lassos. What makes these structures so revolutionary is the scale of their impact. Switchbacks appear to carry enormous amounts of energy, potentially solving a long-standing mystery: why the solar wind accelerates as it moves away from the sun, defying expectations. Normally, you'd expect particles to slow down as they escape a star's gravity, like a ball rolling uphill. But switchbacks might act as cosmic accelerators, pumping energy into the wind like invisible pistons. Then there's the tantalizing connection to coronal heating, one of astrophysics' most stubborn puzzles. The sun's outer atmosphere, the corona, is millions of degrees hotter than its surface, a contradiction that's baffled scientists for decades. Switchbacks could be the missing piece, transferring energy from the sun's interior to its outer layers through these violent magnetic flips. It's as if the sun has hidden transformers in its atmosphere, stepping up the heat where no one thought to look. But the biggest surprise, switchbacks might not be unique to our star. If similar phenomena occur on other suns, they could explain why stellar winds across the galaxy behave in ways our models can't predict. Parker's discoveries are more than just solar curiosities. They're a universal clue written in magnetic hieroglyphics waiting to be decoded. And with every close pass the probe makes, diving deeper into the sun's furnace than any spacecraft before, we're one step closer to reading them. What makes these magnetic hairpins so electrifying isn't just their strangeness, it's the way they force us to rethink the cosmos. For centuries, we've imagined stars as steady, predictable engines. Now we're learning their power is channeled through chaos, twisted into shapes we're only beginning to understand. And if there's one thing switchbacks teach us, it's that the universe loves a good plot twist. On the morning of June 30th, 1908, a fireball tore across the skies of Siberia with the force of 1,000 atomic bombs, then vanished without a trace. Witnesses described a column of blue light splitting the heavens, followed by a shockwave that flattened 80 million trees across 800 square miles, knocked people off their feet hundreds of miles away, and lit up the night sky as far as Europe. But when scientists rushed to the remote Tunguska region, they found something impossible. No crater, no fragments, no smoking gun. Just a silent, scorched forest pointing radially outward like the spokes of a wheel, as if something had detonated midair with unimaginable force. Over a century later, this cosmic whodunit remains one of history's most perplexing natural disasters, and the leading theories only deepen the mystery. The most widely accepted explanation paints the culprit as a stony meteorite, roughly the size of a football field, that disintegrated 5 to 10 kilometers above Earth's surface. The heat and pressure of atmospheric entry would have caused it to explode like a bomb, releasing energy equivalent to 10 to 15 megatons of TNT, hundreds of times more powerful than Hiroshima. This airburst theory neatly explains the lack of a crater and the radial tree fall pattern, matched by modern simulations. But here's the catch: not a single fragment of the object has ever been conclusively identified. Expeditions have combed the swampy terrain for decades, sifting through peat and permafrost, yet the most they've found are microscopic silicate and metallic spherules, tiny droplets of melted rock that could have come from any meteor. That absence of debris fuels wilder possibilities. Some researchers argue Tunguska's intruder wasn't a meteorite at all, but a comet, a loosely packed snowball of ice and dust that vaporized completely upon explosion. Comets move faster than asteroids, amplifying their kinetic energy, and their icy composition would leave little trace, yet even this theory stumbles. The event's timing doesn't align with known cometary debris trails, and the night glow observed after the blast, where skies stayed eerily luminous for days, suggests dust high in the atmosphere, not icy residue. Then there's the fringe favorite, antimatter. The idea goes that a chunk of antimatter colliding with ordinary matter would annihilate in a flash of gamma rays, leaving no physical debris. But here's the problem: such an event would produce detectable radioactive isotopes, and soil samples from Tunguska show none. Even more outlandish, a mini black hole zipping through Earth, or a malfunctioning alien spacecraft meeting a fiery end. These are fun thought experiments, but without evidence they remain firmly in sci-fi territory. What makes Tunguska uniquely haunting isn't just the lack of answers, it's the chilling reminder of how vulnerable we are. In 2013, the Chelyabinsk meteor offered a modern parallel, exploding over Russia with a third of Tunguska's force, shattering windows and injuring over 1,000. But Tunguska was bigger, and if it had hit just 4 hours later, Earth's rotation would have placed St. Petersburg or London in its crosshairs. The blast could have erased a city. Today, Tunguska stands as both a warning and a riddle. It's a testament to the raw power lurking in the cosmic shooting gallery we orbit through, and a humbling lesson in how much we still don't know. Whether it was a rock, an ice ball, or something stranger, one thing's certain: the universe has a way of keeping us on our toes, and the next time something streaks across the sky, we might not be so lucky. Saturn's North Pole hides a storm unlike anything else in the solar system, a perfect, swirling hexagon large enough to swallow 4 Earths whole. This colossal geometric maelstrom has raged for at least 4 decades, possibly much longer, its 6 razor-sharp sides spinning in eerie synchrony, while hurricane-force winds whip at over 300 miles per hour. It's as if nature took a protractor to the planet's atmosphere and etched a 6-sided behemoth into the clouds, defying every expectation of how fluids behave. And the wildest part, we still don't fully understand how it works. The hexagon was first spotted by Voyager in the 1980s, but it wasn't until Cassini's arrival in 2004 that we saw the phenomenon in all its dizzying detail. Infrared images revealed the structure plunging 60 miles deep into Saturn's atmosphere, its walls towering taller than terrestrial skyscrapers. At its center spins a churning vortex, a monster storm with an eye so clear it resembles the calm at the heart of a cosmic dartboard. Yet despite this chaos, the hexagon sides remain unnervingly straight, maintaining their precise angles even as the jet stream propels them forward at breakneck speeds. So how does a gas giant craft something so unnatural? Fluid dynamics offers clues. On Earth, atmospheric patterns like hurricanes tend to spiral or meander, shaped by friction from landforms and oceans. But Saturn is all gas, a frictionless playground where colossal jet streams can carve out stable, standing waves. Some lab experiments suggest the hexagon might be a type of Rossby wave, a planetary-scale ripple that arises when fluids of different densities interact. Imagine shaking a snow globe filled with water and honey. The boundary between them might form temporary geometric patterns. On Saturn, where hydrogen and helium layer like cosmic liquids, something similar could be happening on a planet-sized scale. Another theory points to vortex shedding, where faster-moving gas splits slower pockets into discrete cells, a phenomenon seen when wind flows around islands or buildings, creating alternating swirls. If Saturn's polar jet stream moves at just the right speed, it might sculpt these eddies into a hexagon. Computer simulations have recreated rough approximations, but none fully explain the structure's freakish stability. Earth's polar vortices fracture and reform with the seasons. Saturn's hexagon hasn't wavered in generations. The absence of a terrestrial equivalent only deepens the mystery. Jupiter's poles host chaotic clusters of cyclones, arranged in loose polygons but nothing as precise as Saturn's masterpiece. Neptune boasts the solar system's fastest winds, yet its storms are amorphous blobs. What makes Saturn special? Some researchers speculate its lack of solid obstructions allows patterns to lock in place, like a record spinning without bumps or scratches. Others wonder if deeper forces, hidden rotations in Saturn's liquid metallic hydrogen core, might imprint themselves on the atmosphere above like a cosmic stencil. Perhaps the most haunting question isn't how the hexagon formed, but why it persists. Storms on Earth dissipate within weeks as friction saps their energy. Even Jupiter's great red spot, centuries old, is slowly shrinking. Yet Saturn's hexagon endures, a celestial monument to nature's ability to balance chaos and order on scales we're only beginning to comprehend. Every time we point our telescopes at it, we're reminded, the universe doesn't just follow rules, it reinvents them. And somewhere, 1 billion miles away, a perfect six-sided storm keeps turning, silent and eternal, as if holding secrets we've yet to unravel. Imagine a star cheating death, exploding with enough force to outshine entire galaxies, then stubbornly clinging to existence like a cosmic phoenix. This isn't science fiction. It's the bizarre reality of zombie stars, stellar survivors that endure the unimaginable violence of Type Ia supernova. Take Tycho's star, the remnant of a supernova witnessed in 1572, which blazed so brightly it was visible in broad daylight for weeks. Centuries later, astronomers peering at its aftermath found something chilling. Not just the expanding debris cloud they expected, but hints that the star responsible might still be lurking in the wreckage, twisted and mangled but somehow alive. These undead stars shouldn't exist. Type Ia supernova occur when white dwarfs, the dense cores of dead stars, steal so much mass from a companion that they cross a critical threshold, triggering a runaway thermonuclear explosion. Conventional wisdom says these blasts should obliterate the white dwarf entirely, scattering its atoms into space in a spectacle of cosmic annihilation. Yet a growing number of observations suggest some white dwarfs survived their own apocalypses, emerging from the inferno scarred but intact. It's like watching a building detonate, only to find its foundation still standing amid the rubble. How is this possible? One theory points to failed supernova, where the explosion doesn't fully unbind the star. Imagine lighting a firework that fizzles mid-burst. The energy release is spectacular, but the structure remains. For white dwarfs, this might happen if the nuclear flame front sputters unevenly, leaving chunks of the star unburned. Another possibility involves double detonations, where a surface layer of helium ignites first, triggering a secondary blast in the carbon core. The combined force could eject the star's outer layers while preserving its heart, like a fruit blasted apart but with its pit still whole. Then there's the case of LP40-145, a zombie star racing through the Milky Way at over 2 million miles per hour. This hypervelocity survivor shows chemical fingerprints of a supernova's fury layers stripped away, its core exposed, yet it's still here, a ghostly testament to stellar resilience. Its speed suggests it was flung outward by the very explosion that should have destroyed it, like a bullet fired from a gun that somehow survived the blast. What makes these survivors so revolutionary isn't just their defiance of death. It's the secrets they spill about supernova themselves. By studying their scars, astronomers can reconstruct the explosions in reverse, testing models of how white dwarfs ignite and burn. Some zombies even hint at exotic supernova scenarios, like collisions between two white dwarfs or eruptions powered by unstable isotopes. Every survivor is a cosmic Rosetta Stone, offering clues to decipher the language of stellar explosions. Yet the biggest revelation might be what these stars imply about the universe's chemical legacy. Type Ia supernova are cosmic forges, producing much of the iron in our blood and the calcium in our bones. If some white dwarfs survive, they might leave behind strange, half-burned remnants that skew the expected chemical yields. Could pockets of the universe be richer or poorer in certain elements because of these undead outliers? Zombie stars remind us that even in the cold equations of astrophysics, there's room for the uncanny. They're cosmic paradoxes, rewriting the rules of stellar demise while whispering tantalizing secrets about the explosions that shape the cosmos. And as we find more of these celestial survivors, one thing becomes clear: death, even for stars, isn't always the end. Sometimes it's just the beginning of a far stranger story. Of all the cosmic mysteries we've encountered, few have ignited the imagination like Tabby's star and its whispered connection to alien megastructures. The idea itself sounds ripped from science fiction: a colossal swarm of energy-harvesting satellites built by an advanced civilization encircling a star to siphon its power, a so-called Dyson sphere. When astronomers first noticed KIC 8462852's bizarre, irregular dimming patterns, it wasn't just the data that sparked intrigue. It was the haunting possibility that we might be staring at the handiwork of intelligence beyond Earth. But how much of this is rigorous science and how much is wishful thinking? Let's peel back the layers of this electrifying debate. The megastructure hypothesis didn't emerge from nowhere. Tabby's star doesn't dim like other stars. Its light drops are chaotic, asymmetrical, and deep, plunging by up to 22% in ways no natural phenomenon easily explains. Planets, their transits are predictable and shallow. Dust, it usually scatters light in telltale ways that didn't quite match. A Dyson swarm, though a vast network of orbiting solar collectors, would block light unevenly as its components drift in and out of alignment. It's an elegant fit, at least on paper. The very thought forces us to confront an existential question. If an alien civilization did build such a thing, how would we know? And more importantly, how would we dare to say it out loud? Scientists, to their credit, approached the idea with equal parts curiosity and skepticism. The Breakthrough Listen project trained radio telescopes on Tabby's star, hunting for artificial signals buried in the noise. They found none. Others combed through decades of photographic plates, revealing the star's long-term fading, a trend harder to pin on megastructures, which wouldn't necessarily dim a star over time. Then came the dust. Detailed spectroscopic analysis showed fine particulate matter was likely responsible for at least some of the dimming, though even this explanation left gaps. The dust didn't behave like ordinary interstellar debris. It was uneven, clumpy, and strangely selective in which wavelengths it blocked. Here's where the controversy deepens. The megastructure hypothesis isn't wrong because it's wild. It's problematic because it's what scientists call a non-falsifiable last resort. In other words, it's the kind of idea that's hard to disprove definitively, making it linger in the public imagination long after more plausible explanations emerge. That's not to say it's impossible. After all, if advanced civilizations exist, harnessing stellar energy is a logical step. But science demands more than clever speculation. It requires evidence that can't be explained by natural processes, and so far, Tabby's star hasn't delivered that smoking gun. Yet the fascination endures, and for good reason. The Dyson swarm idea taps into something primal: the hope that we're not alone, and that the universe might be engineered in ways we can scarcely comprehend. It's a modern-day echo of Percival Lowell mapping canals on Mars, or the Victorian-era excitement over the moon hoax that imagined lunar bat people. We want to find cosmic companions, even if the evidence isn't quite there. And in a way, that's what makes Tabby's star so valuable. It's a mirror reflecting not just light, but our own yearning for connection in the vast, silent dark. The real lesson here isn't about aliens. It's about how science wrestles with the unknown. Tabby's star forced astronomers to think creatively, to test boundaries, and to confront the limits of their own models. Whether the answer turns out to be dust, debris, or something even stranger, the journey has expanded our toolkit for studying the cosmos, and who knows? The next time a star flickers oddly, we might just be ready to ask the right questions, even if they sound like science fiction. Because sometimes the universe's greatest gifts are the mysteries that make us rethink everything. Hidden away in a vault at Yale University lies one of history's most impenetrable puzzles, the Voynich manuscript. This bizarre medieval book, filled with looping, alien-looking script and illustrations of unidentifiable plants, celestial diagrams, and naked women bathing in surreal green pools, has resisted every attempt at decipherment for over 5 centuries. But what if the reason no one can crack its code is because it wasn't meant for human eyes at all? Among the wildest theories swirling around this enigmatic text is the idea that its pages contain lost astronomical knowledge, or even messages from extraterrestrial visitors who shared secrets with some long-forgotten earthly scribe. The manuscript's cosmic connection isn't entirely baseless speculation. Flip through its vellum pages and you'll find section after section of intricate astrological charts, constellations unlike any in our night sky, strange circular diagrams brimming with tiny, unreadable annotations. One particularly haunting folio depicts a series of nested spheres, radiating outward like layers of an unknown cosmology. Could this be a star map from another world, a guide to celestial navigation encoded by beings who viewed the universe through entirely different eyes? Fringe researchers point to the precision of these illustrations, arguing that their geometric complexity exceeds the astronomical understanding of 15th century Europe. Then there's the script itself, a flowing, invented alphabet with no clear parallels in any known language. Computer analyzers have shown patterns consistent with genuine linguistic structure, yet every attempted translation collapses into gibberish. Some theorists propose it's a cipher meant to conceal explosive truths, perhaps the coordinates of an alien homeworld or advanced knowledge of planetary movements predating Galileo by centuries. Stories swirl of Renaissance mystics channeling otherworldly intelligences or secret societies guarding interstellar secrets. The idea is seductive that this book isn't just a curiosity but a relic of contact. Mainstream scholars, of course, roll their eyes. To them, the Voynich is far more likely an elaborate hoax or the work of an eccentric herbalist crafting an imaginary pharmacopoeia. Carbon dating places its creation between 1404 and 1438, likely the product of a skilled forger or a lone genius lost to history. The astronomical sections, probably allegorical, reflecting medieval Europe's obsession with astrology rather than actual celestial observation. As for the script, linguists note that even nonsense can mimic linguistic patterns if structured carefully, something a clever fraudster would absolutely exploit. Yet the debate rages because the manuscript refuses to surrender its secrets. Modern AI, armed with machine learning, has thrown its digital might at the text and come up empty. X-ray fluorescence scans reveal no hidden layers or ink anomalies, just centuries of bafflement inked onto parchment. The very endurance of the mystery feeds the fringe theories. After all, if it were just a hoax, why hasn't anyone replicated it convincingly in 600 years? What makes the Voynich manuscript so magnetic isn't the answers it offers, it's the doors it leaves swinging open. Whether it's an alchemist's fever dream, an alien dictionary, or something even stranger, it taunts us with the limits of human knowledge. Every failed decryption, every dismissed theory, is a reminder that history still holds pockets of the inexplicable. And in an age where we've mapped genomes and probed black holes, that's a thrilling thought. Somewhere between fantasy and reality, between Earth and the stars, the truth about this book might still be waiting, not just to be read, but to rewrite what we thought we knew. The moon, our silent celestial companion, seems frozen in time, a barren, airless world with no volcanoes, no weather, and no global magnetic field to shield it from solar winds. But scratch the surface, literally, and you'll uncover a bombshell. Billions of years ago, the moon wasn't just geologically active. It had a magnetic field up to 100 times stronger than Earth's does today. How does a world just 1% of Earth's mass generate, and then lose such a planetary scale force field? This puzzle, known as the lunar dynamo mystery, isn't just academic. It's rewriting the playbook for how rocky worlds evolve, and the upcoming Artemis missions might finally crack the case. Let's rewind the clock. Apollo astronauts brought back moon rocks in the 1970s, and when scientists analyzed their tiny magnetic fingerprints, they got a shock. Certain samples dating back 3.5 to 4 billion years showed signs of crystallizing in the presence of a robust magnetic field. That's like finding a compass needle frozen in time, pointing to a lunar north pole that hasn't existed for eons. The problem: dynamos, the churning cores of molten metal that generate magnetic fields, require heat, convection, and rotation. Earth's dynamo thrives because our planet is massive enough to keep its core molten and spinning. The moon, too small, too cold, or so we thought. Early theories suggested the moon's dynamo might have been borrowed, a fleeting side effect of its violent birth. When a Mars-sized object smashed into Earth 4.5 billion years ago, the debris coalesced into the moon, leaving it scorching hot. For a few 100 million years, its core might have churned like Earth's, powered by leftover heat. But that can't explain the magnetic field's endurance. By the time the youngest magnetized rocks formed, the moon should have cooled into stillness. So what kept the dynamo alive? Enter the core crystallization hypothesis. As the moon's molten iron core cooled, lighter elements like sulfur might have risen, stirring the liquid metal like cream swirling in coffee. This slow-motion convection could have sustained the dynamo far longer than brute force heat alone. Then there's the impact-driven theory. Colossal asteroid strikes during the moon's early bombardment might have jolted the core, temporarily reviving its magnetism like a defibrillator shocking a heart. Computer simulations show impacts the size of the one that carved the Imbrium Basin could have unleashed enough energy to reboot the dynamo for thousands of years. But the plot thickens. In 2017, studies of younger Apollo rocks revealed something even wilder. The moon's magnetic field might have flickered on and off like a faulty light switch, with periods of intense magnetism sandwiched between eerie quiet. This rules out steady-state theories and points to a dynamo fueled by mechanical forces, perhaps the gravitational tug of war between Earth and the moon, flexing the lunar core like a stress ball. Imagine the moon's core as a cosmic generator, spun up not just by heat but by the very dance of celestial mechanics. That's where Artemis comes in. Future missions aim to drill deeper than Apollo ever could, retrieving samples from the moon's south pole, a region untouched by the ancient mare basalts we've studied before. These pristine rocks could hold the key to timing the dynamo's death throes. Even more tantalizing, Artemis might deploy seismometers to listen to the moon's core, searching for echoes of its once molten heart. If there's even a sliver of liquid metal left, it could reshape our understanding of how small worlds cling to magnetic life. What makes this mystery so gripping isn't just the moon's past, it's what it reveals about other worlds. If a modest orb like ours once hosted a powerhouse magnetic field, could lifeless exoplanets we've written off as inert be hiding similar surprises? Magnetic fields aren't just celestial curiosities. They're shields deflecting radiation that would strip away atmospheres and sterilize surfaces. The moon's lost dynamo whispers a provocative truth. Sometimes the smallest worlds hold the grandest secrets, and with every rock we bring home, we're one step closer to hearing their story. From the wow signal's eerie whisper to the great attractor's invisible pull, from rogue black holes drifting unseen to Saturn's perfect hexagonal storm, these 25 cosmic anomalies aren't just curiosities. They're humbling reminders of how little we truly grasp about the universe. Each one is a crack in the foundation of our understanding, a place where the cosmos winks at us and says, "You haven't figured me out yet." Think about that for a moment. In an age where we've mapped genomes and harnessed quantum mechanics, entire chapters of astrophysics remain unwritten, waiting for the next bold mind to turn the page. What ties these mysteries together isn't just their strangeness, it's the way they refuse to fit neatly into our models. Dark matter tugs at galaxies but slips through our detectors. Zombie stars cheat death against all odds. The cold spot lingers in the universe's oldest light, daring us to explain it. These aren't gaps in knowledge, they're doorways, invitations to rethink everything we thought we knew. And that's the thrill of it all. Science isn't about having all the answers, it's about chasing the questions that keep us up at night. So here's to the anomalies, the cosmic rebels that keep astronomy exciting. Maybe one of them will be the key that unlocks a new physics, or maybe they'll remain stubbornly unexplained for generations. Either way, they remind us that the universe is wilder, more inventive, and more mysterious than we could ever imagine. Now it's your turn. Which of these enigmas fascinates you the most? Drop your favorite in the comments, and let's geek out together about the endless wonders lurking in the void. And if you're hungry for more deep dives into the cosmos, don't forget to subscribe. The universe has plenty more secrets to share, and we're just getting started.